Hey everyone, welcome back to Software Testing and Quality Talks by Venkat Ramakrishnan. Today we have with us someone from the cybersecurity community who needs no introduction. But to give you some clue, he is a well-known figure in threat modeling. Still can't guess? Okay, more clues. His accomplishments include helping create the CVE, leading the design and delivery of the Microsoft SDL threat modeling tool version 3, creating the elevation of privilege threat modeling game, and being the co-author of the new school of information security. He is a leading expert on threat modeling, a consultant, an expert witness, and a game designer. He has decades of experience delivering security. His experience ranges from founding startups to nearly a decade at Microsoft. He's a Star Wars fan. If you still haven't figured out, then I definitely need to tell you his name. He is the one and only Adam Shostack. Welcome Adam to the show. Thank you so much for accepting my invite to be the guest in Software Testing and Quality Talks podcast. Let's jump right into the discussion. With the evolving landscape of software development with the use of generative AI for software code, what are your thoughts on additional preventive security measures to be taken towards secure by design, Adam?
So that's a great question. Thank you. I was talking to some friends who work in the code analysis space, and one of the things they said is that it's actually hard to distinguish between machine-written code and human-written code. And so this really drives the need for automated testing, automated analysis of your code as people are potentially building with AI, because the amount of human thinking that's going into it is lower. And similarly, on the AI side, there are, it's not magic, right? It's code, and code can have errors. I'm seeing articles about Google suggesting cooking spaghetti with gasoline, and that everyone should eat a rock every day. And it's funny. It's fun, but you have to ask yourself, what's going on with code quality that these things are coming out so quickly? And, everyone wants to deploy AI tools, but do they really make your product great? Do they make your customers happy? Or do they make your customers want to poke your thing and see how it breaks? And if your customers are going to poke your thing and see how it breaks, why aren't you doing the same thing? And so I think that just leads to the need for test strategy, not only test strategies, but design strategies that result in predictable performance, right? How do I know that my product does what I want it to do once I've got these LLM components or these AI components in it? And it really seems like a lot of companies have decided that that's not relevant, and I just don't get it.
Yeah, the other aspect, what I really wanted to focus on in that question is the generative AI generating the code is creating a lot of concern among the developers. Some of them are saying that, that is not the way to go, but some of them are saying like, we are using code generation, generative AI, and it's very helpful for the productivity of the developers and so on. So do you think there are security issues involved in doing that? I personally feel that there is a lot of review and security related analysis that needs to be done in the code that is generated by generative AI.
I fully agree. There's There's academic studies which show that the code generated by AI has more vulnerabilities than the code generated by humans.
Wow.
Those studies are now a couple of years old, and the companies that are pushing AI insist very loudly that they've gotten better, but I haven't seen a lot of formal, objective, third-party analysis that says, yes, they've gotten better. And so I think that the sane thing to do is to make sure that you're paying close attention, both with tools and with people, to the code that comes out of an AI system.
Right. And it's interesting because whenever there is a new version of LLM released, the usual parameters that are being compared are the same, saying that a percentage of the LLM success has increased a bit, 74 to 76%, and so on. But who is really looking at what kind of code is being compared against between these LLMs, and how are these parameters set, and who is the judge for doing that?
Those are great questions, and nobody, as far as I know, is sharing their security metrics for LLM release. And there's an expert whose work I like named Simon Willison, who talks about the way we evaluate LLMs and their abilities now is vibes and perception rather than formalized testing, and it's sort of bizarre.
Moving on, what specific threat modeling actions or methods would you recommend to tackle generative AI models?
Oh wow, this we could spend a lot of time on this one. The first thing is the LLM itself has specific aspects, and I'll talk about those in a minute. But the LLM is also embedded in a more traditional software stack, right? If it's a chatbot, there's a web server, there's account management, and we've seen issues with those pieces leaking data.
Right.
But as we get into the LLM itself, we should do the normal threat modeling activities of asking, what are we working on? What can go wrong? What are we going to do about it? And did we do a good job? And for a lot of people, what are we working on involves taking an LLM that somebody else trained, either in an API model or in a local deployment model, right? If you download Llama or Phi, you can deploy it locally, and if you're deploying ChatGPT, you deploy it via an API. And you can threat model that, and you can say, what can go wrong with this? And there's a lot of people doing a lot of work on systems for structuring the way we go about analyzing what can go wrong with an LLM. My current favorite comes from a group called the Berryville Institute of Machine Learning, who have released an architectural risk analysis for large language models. And I think it's the best combination that's available right now. And I think we're going to see, not I think, I know for a fact that we are seeing experimentation in this field. We're seeing, for example, OWASP has released a top 10 list for LLMs. I think it's not LLM specific enough. For example, it has things like insecure plugins. I don't feel I need that or anyone needs that in a LLM specific list. I'd prefer to see things like hallucination and memorization.
Right.
MITRE has released an attack analog called Atlas. And I think Atlas is a pretty good model if you are used to the attack matrix. if you're not used to the attack matrix, I'm not sure the form in which Atlas is presented is helpful. And I think that the people doing threat modeling of LLMs are less likely to be familiar with attack than some other folks are. And so overall, I think there's a lot of experimentation, there's a lot of exploration of how to threat model for an LLM deployment, and I expect we're going to continue to see both that experimentation, we're going to continue to see people getting more specific about we're designing this for this use case or for this scenario. Finding ways to fit that into engineering work is going to be very interesting because we're seeing a lot of government activity, ranging from voluntary activity in the US to the AI Act just passed in the European Union. And I'm to be honest, I've spent some time reading, and there's enactment and passage and going into effect, but the AI Act in Europe is not voluntary. It's law. There are large fines if you are using AI and not compliant.
Right.
And so I think we're going to continue to see people explore how to effectively meet the demands of these laws while trying to deliver customer value.
Yes, it's going to be really interesting to find out what's going to happen globally. I took a look at the Atlas, and as you said, it's not immediately obvious as to what I need to do as an engineer to make things happen from the security perspective. It needs a bit of digging in and finding out the exact actions to do. Especially that's challenging when the developers don't pay attention to security at the first place, which we are going to talk about later in this podcast. Thank you for your views on the threat modeling actions. Now let's talk about the threat modeling diagrams a bit. There have been some criticism about threat modeling diagrams being outdated and that they need to be refined. Do you think so too? And if yes, what are the kind of modifications and additions you would suggest on the threat modeling diagrams?
I'm going to try and say this politely. A lot of people have a lot of opinions about threat modeling, and this is old and therefore it's bad. How are people, most of the criticisms I hear, to be frank, are either threat modeling is heavyweight or Stride is old, therefore it can't be relevant. I disagree strongly with both of those. But what criticism are you thinking about?
This one is about the diagram itself. They are saying that the diagram itself is heavyweight and we need to modify a bit so that the diagrams can be come up with in a more rapid fashion, because we are agile and we don't have time and we need to deploy as fast as possible. So, so coming up with a diagram, doing the analysis, going through the design process, everything takes time is what some developers feel, not all. I've seen it in one of the articles, but I don't necessarily agree with that, because I believe that the way you come up with a threat modeling diagram entirely depends on your prowess and how good you are with coming up with the threat modeling diagram, not the diagram itself. But I just wanted to know your views on that. That's all.
So there are people out there, and I was in a conversation on LinkedIn where somebody says the threat modeling diagram needs to include mitigation information. And I'm like, no, that it doesn't need to. You could. But if you're finding that your threat modeling diagrams are taking you too long, the first question I have is, are you going too deep? I like to borrow the agile practice of stopping early, But the other question I have is what's taking the time? Is it drawing the diagram, or is it figuring out what you've built and how it all interconnects? And a lot of the time I find that the people who are saying we don't have time to figure out how this thing works are accumulating technical debt at a pretty high rate, right? They're just throwing features in and it all works today, and eventually they try and make some change and the technical debt comes due. And I think it's useful to use the idea that threat modeling and figuring out what we're working on is big and heavy, is an indicator that you might have other problems, and you're welcome to blame threat modeling for it, but it's not going to get you as far as asking, why is this heavyweight? Why is it slow? Because at the end of the day, a threat modeling diagram, a data flow diagram, might have 5 or 6 types of elements. It's got running code, it's got data stores, it's got data flows, it's got trust boundaries. I don't know how you can simplify that diagramming technique to be any lighter weight. So the idea that it's too complicated, I think the alternative might be no diagram, but other than that, I'm not sure where they're coming from.
Right. I guess probably it's because of the load that they face because of if I use the word is bloating of all the vulnerabilities that they are seeing and how to accommodate that into their design and how to come up with a threat model that would address all this. I think that's where the challenge is. I am guessing.
I'm totally, I hate to say it, but I'm totally happy if threat modeling seems heavyweight because you have problems. It's a, it's a little bit like if you were to go to the gym for the first time in a long time and you can't do a push-up and you can't do a sit-up, and then you blame the gym for being too intensive. This is not the fault of the gym, folks. Right. But let me go back and assume good intent, and let me offer 2 pieces of advice. 1, focus in on the 4 questions. What are we working on? What can go wrong? And if you're finding that that's too big, what are we working on this sprint? What can go wrong this sprint? Are entirely legitimate ways to answer those questions. And if your answers are still really big, oh my gosh, there's so much that can go wrong with what we're building this sprint, I really think that at that point, you're exposing security debt that's accumulated, and finding out how to deal with that is not necessarily a threat modeling specific question.
Right. Let's talk about integrating the secure by design into the software design and development environment. So we have been talking about ensemble programming, the mob programming, and how to bring in different kinds of experts into the design and the software coding process. There are different webinars and talks that are happening about how to integrate security into the design. The common theme that I find in all these discussions is that it's very difficult to make the developers understand all the security aspects. And we need security experts to come in and fill the gaps. And probably the developers can have some basic knowledge about the security and how to design the systems. But that needs to be the presence of security experts in these discussions so that they can provide their valuable inputs. So my question is, what is the ideal balance? How much should the developers know about security, and how much should the security experts fill in the secure by design process?
Yeah. So I hate the term ideal because none of us live in an ideal world, right? We all live in the world in which we live. And so I think that security experts are scarce on the ground. And so we need to encourage normal developers to think a little bit about security as a quality that their code has. And this is the same thing with performance. It's the same thing with usability. It's the same thing with even with testing. You know, when I'm no spring chicken, and when I was growing up, quality assurance and testing was a separate discipline. And now we expect developers to be more responsible for writing unit tests, writing integration tests. And I think it's similar that we need developers to understand a little bit about security. And one of the things about the 4-question framework, and this is actually very important and a little subtle, is I start from the question of what can go wrong. If you're a developer and your answer to that is nothing, and you're not checking errors when they come back when you've made a system call, and you're not checking your input to make sure it matches the sort of thing you expect, good luck with that. But more seriously, I think what we need is better on-ramps, better training, better techniques for helping developers learn in a structured way, because so much of security seems like a grab bag, right? It seems like it's, I should know about SQL injection and indirect object references and phishing and this and that. And so one of the things that I'm fond of as an instructor is this mnemonic STRIDE, which stands for spoofing, tampering, repudiation, information disclosure, denial of service, and expansion of authority. And you can think about all of the ways systems authenticate to each other and people authenticate to systems as preventing spoofing. You can think about a lot, you can put the various threats that we're concerned about into those sort of buckets, and you can use them, and you can just say, how could someone spoof in this system? Are there places someone could tamper with this data? And that gives you this ladder to learning, which is getting us away from there being a dichotomy with security experts on one side and regular developers on another, and turning it into more of a gradient where different look, the team your listeners are probably on, there's someone who knows more about performance. There's someone who knows more about usability, but it's not necessarily a, Venkat is the testing guy, and I'm going to make sure that Venkat writes all my unit tests. It's, I'm going to write my unit tests, and then I'm going to come to Venkat and I'm going to say, hey, I've got this feeling that there's something else I should be testing for. Can you help me think it through? Mm-hmm. So I think that sort of approach results in developers building skill and knowledge in security like all the other ilities, all the other non-functional requirements that their system has.
So, what role do you see the testing and quality folks play in threat modeling process?
So the first thing is testing and quality people are excellent at thinking about the question, what can go wrong? That's a big part of their job. And a long time ago, a fellow named Eric Douglas, who was a test lead in Windows at the time, he's now a VP over at Microsoft, he said threat modeling is just test design, test planning. And I disagree with him a little bit, but I agree with him a lot. And so testing-oriented, quality-oriented people can come in at the beginning and help us answer what can go wrong. They can use the output, right? And some of the output is we're going to change the design of the system. Some of the output is we're going to build controls, and we can test those controls work to meet the requirement that the threat modeling helped to identify. They can do quality assurance work on the threat modeling work products and deliverables. So, for example, they can say, do we have a diagram? They might even say, to go back to a previous question, you know, your diagram here is really more complicated than it needs to be. Your peers are creating diagrams that look like these. They can look at lists of threats. They can look at bugs created to track those threats or mitigate them and say, we've got a good rate of bug closure in a good way, or, wow, we've got a lot of things closed as won't fix. Maybe we should do something about that. So there's lots of ways that quality-oriented people can be absolutely instrumental to good threat modeling and good security.
Right, and they can help a lot with assessing the tools also, because the false positives, they play a havoc in the developer productivity. So they can reduce it a lot by actively participating in assessing the tools and if they are doing the right thing.
Yeah, although let me say, if you're the tool that gives us the most false positives tends to be static analysis.
Mm-hmm.
And if that's killing developer productivity, rolling it back a little bit, tuning it so that it produces fewer false positives, arranging it so that the static analysis runs in a tighter mode on new code so you're not adding problems.
Mm-hmm.
There are tactics that you can use, and there's lots of people who will talk about this under subjects like optimizing static analysis. And I think it's tremendously important to not believe that static analysis can be rolled out quickly and easily, especially across a large code base.
Correct.
It's a process. It takes time.
So let's get back to threat modeling and vulnerability management. So threat modeling and vulnerability management in place, even in enterprises. Organizations are lacking security posture. Like they do not patch, they let some very silly mistakes take over, they do not follow security best practices and so on. What do you think is the reason for all this? Are they lazy or what's happening?
So I don't think they're lazy. I think the problem with, and I don't mean to be confrontational about this, but the problem with the question of why don't you follow best practices, the work involved in this can be pretty extreme. and to say you have to do this and you have to do that when it's not clear why, right? There's legitimate complicated arguments about, do I really have to update all my dependencies all the time? And in an ideal world, you would cut out the pieces of the dependency that you don't need and can't reach, which would make your binaries smaller, you make your deployments faster, and that's work. And so when we ask why people don't do work, I think the best answer is there's a lot of work to do. And then I get to the question of how do we reduce that? How do we make it easier? And I mentioned in threat modeling, we use the simplest diagram type that we can. I'm a fan of stop early because the load, not only from these recommendations, but also the load that comes from various compliance regimes is very, very high. And so I think we need, in general, to be thinking about how do we prove the effectiveness of the things we're asking people to do as security people? How do we drive the cost of those things down? Because I think that's the biggest thing, is you make things easier to do, people are more likely to do them.
Right. And then the education part of it, I think it's most important because we need to constantly be educating the team on security. So what are the things that you think we can do effectively to make this education happen?
So the first two things to do are, number one, make it relevant to them. And number two, make it entertaining. And I'm just going to draw on threat modeling. And when I say make it relevant to them, the reason I start from the 4-question framework of what are we working on and what can go wrong is because everyone feels like they have an answer to those questions. If we ask them respectfully, we listen to their answers. I've never met a person who doesn't have a perspective that something could go wrong. And, their answers are more and less useful, etc. But the other thing to do is we should make it right. So before I say the other part, if you're trying to teach someone and they don't understand why this thing matters to them, they are way less likely to pick it up and act on it. And insecurity today, we're either blessed or cursed with a lot of good examples in the news. And so when I teach, I teach both via Shostack and Associates, and I teach at the University of Washington. And when I'm teaching at the University of Washington, I start my classes with a segment on security in the news. And then we tie the stories that students are bringing up to the subject matter of the day. And I do that as a motivational thing. The second thing that I think is really important is let's make it fun. And so, for example, my latest book, Threats, What Every Engineer Should Learn from Star Wars, uses, Star Wars as a way to make learning fun. And so it opens with this question of how does R2-D2 know who Obi-Wan Kenobi is at the very beginning of the movie? There's this famous scene where R2-D2 only plays a little snippet of a video for Luke Skywalker, and it's the "Help me, Obi-Wan, you're my only hope" segment. But if you give people just a minute of fun and you meet them a little bit where they are, they're way more likely to pay attention to everything else you have to say.
Yes, I agree. And I've seen that in a lot of environments. So there is something called threats book that I'm seeing a lot from your posts and things like that. So tell me a bit about what that is all about.
Yeah, so it's about threats. And one of the things that I learned in teaching was that along the way, I had learned a lot about these threats. And so the book is organized around the concept. It's organized around stride, which I've mentioned. And then it goes into kill chains, things like the Atlas system, which I've also mentioned. And the idea is people need this structured introduction to a topic. And when I looked around, I really didn't see that structured introduction. And so I wrote one.
And to get a glimpse of a bit more glimpse of what is inside the book, so what are the things that one can expect? So it's is it more with examples, real-time examples, or okay?
It is. And it starts, each chapter is structured very much the same way. So it starts with a little vignette from Star Wars. Your readers should know the fun of it. And so, for example, the information disclosure chapter starts out by pointing out that Star Wars itself is the story of a data breach and its consequences, right? It's all about this stolen data tape and what happens. And so it's a little bit of fun. And then it talks about the concept of confidentiality, the threat of information disclosure, which is a violation of that. It gets into a model of, and I haven't gone back and looked at the chapter, so this might be a little bit off, but I'm sure it talks about information disclosure when data is flowing over a network, when data is on disk. It talks about metadata, the idea that if you and I are communicating, the fact that we're on a Zoom call is probably visible to somebody watching our network traffic. So that's another form of information disclosure, which leads us into privacy. It then talks about how to address these things. So you can use access control lists to control permissions, or access control lists to control files on disk. You can use encryption as data flows over a network to protect that data, and then it gets into a little bit of key management and how that's difficult. Then it goes into information disclosure for AI, IoT, cloud, and a few other specific circumstances. And so each chapter like this is designed to introduce one key concept. And the goal of the book was to say, if you're a company and you want to train every engineer on cybersecurity, what should every engineer know? And that's where the subtitle comes from, right? What every engineer should learn from Star Wars is a little bit of a cheat to what I think every engineer should know about cybersecurity.
Interesting that you mentioned about cloud, because I just read an article in LinkedIn about how the cloud native applications have security challenges, like the attackers moving across and getting into other users' spaces and trying to access the data and information, and how we can address that. It's a pretty evolving topic, and I'm really excited and interested in see how it goes. Which brings us to the next topic I would like to talk about, which is the stride itself has been there for a while with all its variations.
Mhm.
Do you think Stride needs to be modified or need to be refined in any way, or any new things need to be included in that, or is it sufficient to move forward, especially with the generative AI and all that coming up?
So it's a really interesting question, and I think that the core of Stride is an excellent model that has a nice balance between being specific and being generalized. And because it's generalized, for example, the thing you were bringing up about cloud threat modeling is about information disclosure. When Stride was created, there was no cloud computing, but the information disclosure threat, because it's a fundamental, because it relates to the fundamental property of confidentiality, helps us think about cloud. Now, there are updates. Cloud, let's stick with cloud. Cloud created a new form of denial of service attack, which is denial of service on your budget. So an attacker can help you spend as much money as you're willing to spend. Now, some people would argue the cloud vendors do the same thing, but I don't want to go there. But I think that's a good example of how the fundamental category of denial of service can evolve. We can add a budget prompt to it to think about that. But we can also think about cloud data center unavailability as just an element of denial of service, which is very similar to the machine in my data center ran out of compute cycles or became unreachable. And so the thing that I really like about Stride is that it turns out to be very durable. And so I think it's a useful thing for every engineer to learn about.
Yeah. I too agree that Stride is very durable, and it has a lot of things foreseen in advance, and taking care of the advanced technologies also in its purview. So that's great. So great, Adam. It has been a fantastic discussion on several aspects of threat modeling. Uh, just a bit of knowing you better. What are your hobbies and interests apart from work? What do you do for fun?
Well, I mean, obviously, I watch Star Wars. But really, actually, at the moment, my family is deep into a Star Trek rewatch. So we're into season 6 of Deep Space Nine right now.
Oh my God.
Um, and I've spent a lot of time talking about Star Wars. So let me say something about Trek, which is that I really do enjoy Trek as well. I think in a lot of ways the characters are more developed, and just I don't want anyone to think I'm slagging on their favorite series. So
Okay. Do you watch a lot of movies also?
fewer movies. I like longer form and the storytelling that goes into modern TV, where things are really interleaved in ways that reward watching a whole series, and that's just a little harder to fit into a movie.
That's pretty interesting. That's directly opposite to me. I like
Ah,
watching 10-minute shows.
oh, okay.
I have a very limited attention span, so to speak. So uh, it's funny that I'm doing podcasts for 30 to 40 minutes.
I think one of the great things about the world today is there are so many different forms and so many different ways in which people can engage ranging from, the super short microblog formats to the longer ones, to videos, to podcasts. And I just think it's a phenomenal time to be alive because we have so many varied information sources and so many varied entertainment sources that are available to us.
Yeah, absolutely. And I use most of them, all of them. I use podcasts, and I watch a lot of thriller movies,
Okay.
which keeps me going. I get bored very often, so I try to entertain myself in different kinds, listening to Western classical, dancing salsa, and all that.
Awesome.
Yep. We should meet sometime in person and talk more and get to know the work that we are doing. And thank you so much today for participating in the podcast. And I would like to thank you on behalf of all the viewers from the Software Testing and Quality Talks. And I look forward to connecting with you in LinkedIn and other places. And I would also encourage all viewers to connect with Adam. So in LinkedIn or otherwise, and where his tools of wisdom are available, which will be helpful for our work in the quality and testing space.
Yes, happy to connect with anyone on LinkedIn. And I want to encourage people who found this interesting. I have a blog that tries to focus a lot on threat modeling at shostack.org/blog. And Venkat, I look forward to meeting you in person. This has been great.
Absolutely. Thank you so much. Thank you so much for your time, Adam.
You're welcome. Have a great day.
You too. Bye-bye.
Bye.